Welcome back, algebra folks. Here, we're going to take a look at simplifying this seemingly harmless expression, but one that I think is actually very interesting. So the expression that we're going to look at is x to the m divided by x to the m. And there's kind of two approaches that we could take with this. One would be to kind of just think about it logically. Well, let's talk about this. X to the m divided by x to the m. One way, well, let's think about this. X to the m is what it is, right? 3 to the 5th. 7 to the 14th or something. But whatever it is in the numerator, it's the exact same thing in the denominator, in this example anyway. So we have something divided by the same thing. And almost every time, I say almost every time because we want to be careful of this, and I'll mention this at the end of the video, it's always equal to 1. For example, 5 over 5, or 724 over 724. It's always going to equal 1. And so this should be no different, even though there's exponents in it. It's just going to be equal to 1. So x to the m over x, that's really ugly, I apologize, is equal to 1. Right? But there's another thing we could take a look at. Another approach to this we could take. One would be to use one of the properties that we talked about previously. And that one is going to be this property. Right here. Let me highlight it. The second one here, involving fractions or dividing exponents. And the idea here is that, well, if I use that idea, this really just simplifies down to, or is equal to, excuse me, x to the m divided by x to the m is equal to x, and I will subtract the exponents. M minus m. Again, remember, if I had, say, x to the 7th divided by x to the 2nd, I would simply just have x to the 7 minus 2, or x to the 5th. Oh, sorry, I covered that up right there. Alrighty, and so this would be exactly the same thing. It's just now, well, m minus m, a number minus itself, is equal to 0, right? And so, well, m to the m minus m equals 0. And so x to the m over x to the m is equal to x to the 0. But we also said over here that's equal to 1. And so this draws us to the conclusion here, sorry, and that x to the 0 is actually equal to 1. And this is something that throws a lot of people off, because a lot of times people want to say x to the 0 equals 0. And I think the reason people are used to this is because they're used to seeing x times 0 equals 0. Remember, these two things, they're different. They're totally different, right? And here's one explanation as to why that is. Well, first off, these two things should kind of show you already. With this explanation here on the left, it totally makes sense. You take any number and divide it by the exact same number, it's going to equal 1. Again, most of the time, I'll explain the one time it's not. Over here on the left side, or sorry, the right side, this is using our properties of exponents, which has worked so far, so why would it not work? And so that those two ideas together, and they both came from the same starting place, x to the m. And so the same starting place produces x to the 0 or 1. That must mean that x to the 0 equals 1. But here's another explanation. Think about this. We'll use an actual numerical example here. Pretend I have 2 squared, right? So that's equal to 2 times 2. Nothing special there. If I have 2 cubed, that's 2 times 2 times 2, right? When you're going forward, when you increase the exponent by 1, you're just multiplying it by another 2 times 2. If I wanted to get 2 to the 4th, that would just be times 2 again. So I have 1, 2, 3, 4 2's. If we think about patterns, well, going forward, I would multiply by 2. So going backwards, I would divide by 2, right? And so here, I'll have divide by 2 to get 2 to the first power, which would just be 2, because that makes sense because there's just 1, 2 there. If I follow this again, divide by 2, that'd be 2 to the 0. And well, what's 2 divided by 2 would equal 1. And so 2 to the 0 would equal 1 by that logic. Another way, and this is how some people like to think of it, is that in any exponential expression, 2 squared, 2 cubed, 2 to the fourth, you can just picture that there's actually an invisible 1 right there anyway. Because 1 times 2 is still 2. 1 times 2 times 2 is still 2 squared, or 4, and so on. And this right here just says there's a 1 there, and how many 2's are there? There are none. And 2 to the first, there's a 1 that's invisible. And how many 2's? Well, there's just 1, 2. And so on like that. And so this picture maybe provides, I hope, provides another explanation as to why x to the 0 equals 1. And we're going to definitely want to put that along with our properties in our mental exponential toolbox. Okay. Now, before we leave, I just want to mention one thing. I mentioned several times that something divided by itself is 1, except for some scenario, and here's the scenario. Oops. X divided by x is equal to 0 unless, and you might have thought about this example, and I think there's a whole article on this about how you could ask Siri this question if you wanted to, unless x equals 0. Because we really don't want to say that 0 over 0 equals 0. We kind of try to avoid saying that. And there's multiple explanations as to why that is, but we actually would refer to 0 over 0 as an indeterminate. Meaning we cannot determine what it is. And you'll see this a lot more when you get into calculus, in that depending on the scenario you're looking at, 0 over 0 could equal 1, it could equal 0, it could equal something else entirely. And so we don't want to say that 0 over 0 is anything. We just call it indeterminate for now. But when you're working with these problems, so for example, if I was to say x squared over x squared y, pretend, we're just going to assume that x is not 0 in this case. And so it's totally okay to say, hey, x squared over x squared, those form a giant 1, and so it just simplifies to 1 over y. Alrighty? So there you have it, an explanation, or several explanations, I guess, and hopefully at least one of them sticks and makes sense, that x to the 0 is actually equal to 1. At some time I'm going to figure out how my camera flips and stuff. Okay, but we're going to take a look at some more questions. Actually, there's just one more property that we really want to look at, but it does show up a lot, so we want to get through that. But I'll cut it here and see you in the next video.